Today we're going to look at graphing polynomials. So we're going to build on what we did yesterday of looking at the basic shapes and use that to help us graph our functions. Now this one here we need to go ahead and graph. So we're going to use a t-table or an xy chart. We know we can't use the idea of a slope in your y-intercept because we know it's not an equation of a line because we have exponents higher than 1. Now, we want to look at our leading coefficient and our degree to tell us the basic shape of this graph. Since we know it's going to the third power, it's an odd degree, you know it's got to go up on one side and down on one side. The question is, does it go like this, or does it do the reverse, coming from the upper left going to the lower right? Well, you know that since we are dealing with a negative coefficient and it's odd, it needs to come from the upper left and go to the lower right, and that's what we're showing down here. Now, whether it's the shape of the first one or shape of the second one doesn't make a difference. All we know is that it's got to come from the upper left and go to the lower right. Whether it levels out or has the bump in the middle, we'll find out after we graph it. So we're going to start off by just choosing values for x, near x being 0. And we need to make sure we choose enough values for x so that we get the whole basic shape that we have here. Since we know it's odd with the leading coefficient being negative, we got to get this shape here. So we got to choose enough points to get that shape. So I have a table here. I just chose some x values near 0. Now we'll go ahead and plug those in. Take -4, plug it in. Remember when you plug in a negative that you got to put it in parentheses if you're going to use your calculator, or you can do it all in your head. Doesn't make a difference. So we plug in the x values and we get these outputs. Then we need to go ahead and plot these points. So you got to go 4 units left, 5 units up. 3 units left, 4 units down. 2 units left, 3 units down, and so on. Just go ahead and plot all those points. Sketch your graph. And we get this. And you'll notice we do get the general shape that we were looking for, coming from the upper left going to the lower right. We also want to go ahead and take a look at our zeros. You know your zeros occur whenever you are crossing the x-axis. So we have one that's about here, we have one that's about here, and then we have one right here at x being 1. So where we have x being 1, we have one here that occurs between -2 and -1. And then we have another one that's occurring between -3 and -4. We also can see that when we look at our t-chart, we know x being 1 is a 0 because we get an output of 0. We know that we have a 0 between -2 and -1 here because the y value switch from a positive to a negative. We also know we have another one between a -3 and a -4 because we switch from a positive to a negative. Whenever you switch from above the axis for positive to below the axis for negative, you know you have to cross your axes, therefore you have a 0. So let's go ahead and do that one for this one here. Since it's an even degree, you know it's going to do the same thing as you go far to the right and far to the left. Since it's a positive in front, you know that you're going to be going up on both sides. So therefore, the general shape of the graph will have to be one of these two here. Either kind of like a U or kind of like a W. Which one of these we'll find out after we graph it. So we need to make sure we choose enough points in our t-table, XY chart, to get that basic shape. Here I've chosen these values. Take -2, plug it in for your x. Take -1, plug it in. Take 0, plug it in. Take 1, plug it in, and so on. Plot these points. 2 to the left, 13 up. 1 to the left, 3 up. 0 to the left, 5 up, and so on. And then we get this shape here. If you make a t-chart, and you don't get the basic shape that you know you should as you look at these in the lower left corner, That means you got to continue to choose more points until you get that basic shape. Now we want to estimate the zeros. You'll see it crosses near 1, but not exactly at 1. It's between 1 and 2 that it crosses. You'll also notice between 1 and 2, you go from 1 above to 3 below, so it's got to cross. Also looking at your graph, you see from between 2 and 3, it crosses. Looking at your chart, you'll see at 2 you're below, at 3 you're above, so you know you got to cross in between. Well, here we have maximums and minimums. Here we have a global or absolute maximum because it's the highest point of the entire graph. Here we have a global or absolute minimum because that's the lowest point of the entire graph. Here we have a local or relative min because it's the highest point in this area of the graph. Here we have a local or relative min because it's the lowest point of this area, not of the whole graph. Now, most functions will have one or all of these occurring. Now, it is possible for it to have none. An example of that would be a diagonal line because it has no max or mins. So let's go ahead, use our idea of what shape this should be, graph it, and then we're going to estimate our zeros and try to find the x-coordinates of our max and mins. We know that this graph here is odd, so you know on one side you got to go up, on the other side you got to go down, so you know your basic shape will be like this one here or this one here in the lower right corner because it's got a positive leading coefficient, so that means you got to go up as you go to the right. Now, since it goes up forever, goes down forever, you know you're not going to have any absolute max and mins because it goes up and down forever. But we could have relative maximums and minimums. So that's what we're going to be looking for. So we're going to go ahead, make our t-chart, plot our points from our t-chart, and look at our graph. Estimating our zeros, we see we have one here at -1. We see we cross between 1 and 2. We see we cross between 3 and 4. When you're looking at your relative maximum, your highest point in this area of the graph right here, you see that occurs when x is 0. Your lowest point of this area of the curve looks to be about 2.5 to 2.6, something around there. Now, you'll notice I have generated a fairly accurate graph here, so I could see that. But if you're looking only at your chart here, when you're talking about that area here, your lowest value that you have on your chart here is at -4. When does -4 occur? What x value? That's at your 3. So they're not going to be looking for an exact precise value. They're going to look for an estimate based off of your t-chart. And so that's why we're saying x is 3 for your minimum rather than looking at the accurate graph that I have displayed here.